right, so now we're on to solving systems of inequalities. So exactly the same as solving by graphing, except now we've got inequalities. So remember that inequalities, whereas an equation has, you have a solution to an equation like x equals 4. That's the only answer it could be, right? It's only 4. But if you have x is greater than 4, there's a whole range of answers that we could have there. So we could have 5, we could have 10, we could have 1,000,003, there's 0 in there, 1,000,003, right? We can have an infinite amount of answers for that. So what we're really doing when we're finding systems of inequalities is you're finding the range where those two things overlap. So I think one thing that's really helpful is if you have two different color highlighters or colored pencils or what have you. Highlighters you need to be careful because they will bleed through the paper, but colored pencils work really well. Highlighters work really well so you can see where the overlap is of the two shaded areas. So that would be my advice to you, to get those and have them ready for this section. Okay. Another thing I would caution you on is in this unit, even though things are put into standard form, I would suggest changing them to slope-intercept form to make sure that you've got that sign right. So I would advise that. So remember, you're just going to move the x term over and then divide by the coefficient in front of the y. With inequalities, if that coefficient in front of the y is negative, it will also change the sign. I want you to think about the opposite, or the opposite. That will help you with that. Okay, so let's go with this first one. So I need y isolated, so I'm going to move my 3x to the other side by subtraction. So it'll be less than negative 3x plus 4. Then I've got to divide everything by 2. So that would give me y is less than negative 3 halves x plus 2. So I'm going to go over and start at 2. Then I'm going to go down 3 and over 2. Okay. Here's what I want you to think of. Any point that would be included on that line, if I were just to graph y equals negative 3 halves x plus 2. So if I had, let's change that. That would be a solid line between those 2 points and continuing on, right? However, when it's less than, that means that any point that's on that line would not satisfy that inequality. So that's when we use a dashed line. So you can write this right at the top. So for less than or greater than, you're going to use a dashed line. Less than or equal to, greater than or equal to, you're going to use the solid line. An easy way I explain is if you see a line, graph a line. If you don't see a line, then it's a dashed line because it can't include, it can be greater than that line or less than that line, but it can't include any point on that line. So this would be a dashed line because that is a less than. And then I want you to think logically where less than would be. And you always want to use your intercept. It's the easiest way. So less than, so our intercept is at 2. So think of a number that's less than 2. Well, 0 is the easiest. 0 is definitely less than 2. So we're going to shade on this side of the line. And this is just a single inequality graph, so I'm just going to graph like that. Okay, so here's a little instruction on that. So we've got y is bigger than or greater than or larger than. And anytime it's greater than, you're going to graph on top of that line. So just ask yourself, what's a number greater than my intercept? So I would write on here, use the y-intercept as your guide. It really will help. It's already there. You might as well use information that's right in front of you. Okay? So, if it is greater than or equal to, less than or equal to, or greater than or equal to, you're going to use a solid line. If it's greater than or less than, you're going to use a dotted line. If it is greater than or equal to, you'll shade above the graph line. Less than or equal to, shade below the line. So I know some of you get kind of hung up on this, but it's really not a trick question. Just think of greater than is usually higher, less than is usually lower. And you're always using the y-axis as your where you're starting with that. Okay? So let's go to the second page. Let's just do some quick. So now systems, now you're just graphing 2. So the first thing I would do is make sure that everything's in slope-intercept form. So my first equation's fine. Let's move this one around. So now I need to add the x to the other side. So I would get x minus 4. Now I've got to divide by negative 2. This is where the wrinkle comes in with inequalities. If you multiply or divide by a negative, the inequality will flip around. So think about opposites. So if it was less than and it's being divided by a negative, it's going to make it a greater than, and vice versa. The inequality will change direction. Okay. So, for example, this is being divided by, it doesn't matter what number it's being divided into, it matters what that coefficient is in front of the y. Since that's negative 2, that is going to flip my equation, my inequality, and I would get negative 1/2 x. X divided by negative 2 is the equivalent of negative 1/2 x. Negative divided by a negative is a positive 2. So now I've got two inequalities to graph on the same coordinate plane. So let's do the first one. I know that y equals 1 is a horizontal line at negative 1. Because this is greater than or equal to, it's going to be a solid line at negative 1. And I need to find any number that is greater than negative 1. So 0 is greater than negative 1. And I'm going to go ahead and graph that. That's going to be my yellow area. And I'm going to shade everything above that line in yellow. Now I can graph the second line. I'm going to start at positive 2. And my slope is down 1 and over 2, or up 1 and to the left 2. That is a greater than sign. It does not have the line underneath. It's not a greater than or equal to. So that is actually going to be a dashed line through those points. And that is greater than. So I'm going to go to my y-intercept, and pick a number that's greater than 2. Well, 3 is greater than 2. That's right above. And I'm going to shade everything above that line. So you can see with the highlighter especially, it's very easy to see where they overlap. So what you actually can do is you can kind of highlight that area that is overlapping those. So it's this whole range out here. You could also choose any coordinate out here to check to see if you really graphed it in the right area. So it's always easiest to pick something that involves a 0. So to me, I would either use 0, 3. That's that point right there. You could use 1, 2, 3, 4, 5, 0. So let's check 5, 0. That's that point right there is 5, 0. Let's check it in here to make sure that that is true. So our y value is 0. 0 is greater than or equal to negative 1. That is true. Our second equation, we use the opposite of that. And again, you don't have one point to check now. When you had a system of equations, you had a point where they crossed, you had one point to check. Here, we've got a million points we could check. We're just checking an easy one that's got a 0 as part of its coordinate pair. So the opposite of my x value would be negative 5. Negative 2 times 0 is just 0. So negative 5 plus 0 is negative 5. And I'm just verifying to see that negative 5 is less than negative 4, which it is, so that checks out. So absolutely you can check these as well. Okay? All right, let's go on to example 3. First thing I'm going to do is change those both into slope-intercept form. So the 2x is going to get pushed over in both cases. And then, let's see, for my first one, for both of them, I would need to divide everything by 4. So I'm going to do the first equation here. 4y plus, excuse me, I already moved it, is greater than or equal to negative 2x minus 8. I need to divide everything by 4. So I get y is greater than negative 1/2 x minus 4. Let's just double check that. So I move my 2x over. Then I need to divide everything by 4. So negative 8 divided by 4 is negative 2. Ha! Good thing I checked that. Negative 8 divided by 4 is negative 2. Were some of you yelling at me? Probably were. Negative 2/4 reduces to negative 1/2. 4 divided by 4 is cancels. Okay. And then on the bottom I would have the second equation here. I would have 4y is less than or equal to negative 2x plus 12. Dividing everything by 4. So y is less than or equal to negative 1/2 x plus 3. So let's see what kind of happens here, because right off the bat notice that I've got the same slope in both inequalities, which tells me I'm going to have parallel lines going on. So, and I know with systems of equations that means I have no solution. But I don't know if that means the same thing here. Probably depends on the signs we've got going on. So let's figure that out. Add that back in there. So my first equation, I'm going to start at negative 2. My slope is negative 1/2, so I'm going to go down 1 and over 2, or up 1 and over 2. That is going to be a solid line. And since that says y is greater than, I'm going to shade everything above that line. A different color highlighter, why not? And then my second equation, I start at 3. 1, 2, 3. And my slope is the same. So these lines are going to be parallel. I'm going to go down 1 over 2, up 1 over 2. That's also going to be a solid line. And it's going to be everything less than or equal to. So I'm going to go to my y-intercept. Any number less than 3 will choose less than 3. So it's going to be on this side of the line. In this case, that little channel in between is going to be my solution set. Again, if you want to kind of outline it with a darker pen so you can kind of see where your solution set is at, I think that's a great idea. Any number in there will satisfy both of those equations. So let's pick one. And again, I'm picking something with a 0 in it because I like it. So you can pick 0, 0 is one of the equations in there, isn't it? That would be a really easy one to check up here. So 4 times 0 is 0. 2 times 0 is 0. Is 0 greater than or equal to negative 8? Well, 0 is always greater than negative, so that's true. If I plug those into the second equation, I would get 0 plus 0, which is 0 again. Is 0 less than or equal to 12? And of course it is, so that checks out. Anytime you can use a coordinate, 0, 0 is a fabulous one to use if you can. If that's not in your solution range, use 0, 1, 1, 0, 2, 0. Like over here, we use 5, 0. Make sure one of your coordinates is 0. Make the work easier on you. Okay? So, in number 2, they want to check and see if 6, negative 1 is a solution to this system. So let's go over 6. 1, 2, 3, 4, 5, 6, negative 1. Well, let's see if that is. It should be, because it's along my solid line. If it had been along my dashed line, it wouldn't have been a solution. But let's plug it into both and see. So my y value is negative 1. So is negative 1 greater than or equal to negative 1? Well, it's equal to negative 1, so that one's okay. The opposite of let's check in the second inequality. My x value is 6, so negative 6 minus 2 times negative 1, well, that would give me 2. Should be less than negative 4. So negative 6 plus 2 is negative 4, but negative 4 is not less than negative 4. It's equal to negative 4, but this is only a less than. So that's not going to be, and that's because it's got this barrier. One of them is not an equal to. Okay? Good. All right, and this time I really am going to play music for you while I graph number 4 and 5 and check to see that 2, 3 is actually a solution of number 5. So. channel in between. There's no overlap. There's no area where the purple and yellow coexist, so that is a no solution. And check to see if 2, 3 is a point. So 2, 3 would be over 2 up 1, 2, 3. So that's on my dashed line. So that's not going to be a solution. Let's check it algebraically just to prove it. So my x value is 2. So 2 is greater than or equal to 0. That's fine. 5 times 2 is 10. Minus 2 times 3 is 6. Is less than 4. So again, we have 4 is not less than 4. So this makes it not a solution to the system. Okay, pretty easy. We will work on that in class. Thanks.